This time, when completing the square, rather than leaving it in the radical form, we're going to round to the nearest 3 decimals. So first, as always, we need to get the c value over to the other side of the equal sign. So we're going to subtract 4 from both sides. It cancels out on the left-hand side, and we're left with x squared minus 7x plus blank equals negative 4 plus blank. Now what goes in that blank space is half of the b value, half of negative 7. But we're going to write it as a fraction. So we're going to write it as negative 7 over 2 squared on both sides. From here, on the right-hand side, we can simplify. Negative 7 over 2 squared is going to give us positive 49 over 4. When you add that to negative 4, you're going to get 33 over 4. On the left-hand side, we set up our binomial squared. We take one of the x's and just the negative 7 over 2. So I'm going to write it as x minus 7 over 2. And now we solve for x. So to solve for x, we take the square root of both sides. So it cancels out on the left-hand side, and we're left with x minus 7 over 2 equals, you're taking the square root of 33 and the square root of 4. Square root of 33 isn't a perfect square, but the square root of 4 is. It's going to give you positive or negative 2, and the square root of 33 stays in the numerator. Notice again that the denominators should always match up. Once you take the square root, this is over 2, and now this is over 2. The last step to solve for x is to add 7 over 2 to both sides. That leaves us with x equals, we're going to write it as 7 plus or minus radical 33, and that's all over 2. Now, to write it to the nearest 3 decimal places, you're going to use your calculators. So it's either going to be x equals 7 plus radical 33 over 2, or x equals 7 minus radical 33 over 2. When we plug this into our calculators to the nearest 3 decimal places, you should be getting 6.372. And when we plug the second one into our calculators, you should be getting 0.628. These are the 2 roots of the equation, the 2 zeros of the function. These are the x-intercepts on the graph.